Good morning. Being a little cantankerous today. All right.
Good morning.
Well, he changed his picture so we don't see his dog anymore.
Hey,
Hey, what?
nothing.
Exactly. All right. I should see you, not. 1, 2.
Yeah, I'm eating my tacos, miss.
What did I tell you about lunch? Is this
You've
lunchtime?
been eating tacos all day.
But this is
Hey,
not.
Michael, be quiet.
All right. So, okay.
Miss, I'm going to turn on my camera in a few minutes.
It better be soon or I'll kick you out. All right. So,
No, miss.
what we are doing today is what? See if I remember.
Math.
Yes, math. But what math?
We're having a
Did you all
Quiz,
get
right?
email
Test.
yesterday? Did you all get email yesterday?
Yeah, I figured that out.
Okay.
Yeah.
Yeah, I think I did.
Okay. I sent you the test for chapter 8. And what I'm going to do is we're going to go over some stuff. You're going to work on some of the problems. We'll go over some stuff. You'll work on some of the problems. And hopefully we can get through some tips and hints for a lot of it today in class. And then you can finish it on your own and send it to me sometime over the weekend. Okay?
Did you got my Gmail?
Yes. That you said this morning?
Yeah.
Yeah. I haven't got to pull it up yet, but I saw that I had one from you.
All right.
Okay. Because it comes across on my phone too when I get them, but I can't pull it all up through there. Okay. So what I have is up on the board, we had done some examples yesterday for quiz 4, which a lot of you did do better on quiz 4 than you did on the quiz 2 and 3. Okay. Some of you went back and fixed your quiz 2 and 3 a little bit, so that was good. Okay. But I told you yesterday at the end of class, like the last, or in the email, I think I told you in the email, that the last 3 problems that were on the test are like 3 of the problems from quiz 4 that we did yesterday. So I still left those examples up here so I can tell you which problem that they're like. So if you did actually get your test printed out, you can write that down. Otherwise, you should have these notes, the examples that I did yesterday. So you can write down the problem number that it's like on those notes, so you know when you do look at your test, you can match them up. Okay, so like this first problem that was like number 1 on the quiz is like number 15 on the test. Okay, the first problem that was like number 1 on the quiz is like number 15 on the test. The second problem that was like number 2 on the quiz, this is like number 16 on the test. The one where we have to find the radius using the distance formula. And then the one where we have to do completing the square is like number 17 on the test. Okay. So the first example from yesterday where you actually had to graph the circle is like number 15. This one that we did yesterday, I think it was like number 2 on the quiz, is like number 16 on the test. And then this one that we did yesterday, like number 3 on the quiz, is like number 17 on the test. That's the last 3 test problems. Like I said, everybody should have those examples still written down where you did them for the quiz notes yesterday. So you should be able to just label like number 15, like number 16, like number 17. So that way you'll have that. Okay?
Yeah.
Okay, everybody understand that?
Yep.
Now the next thing that's talked about on the test is on number 1, there's nothing I can really go over with for you because number 1 on the test is just your definitions: chord, diameter, radius, segment, secant, tangent. If y'all don't know what those are by now, because that's like the whole chapter, then, and a lot of that stuff that you should have had since like at least middle school, because I know I've taught it to them. So this is stuff you should have had for a while. So number one, you're just matching the definition with what it is. It gives you the picture to look at. All those definitions are in section 8.1 and 8.2 in your notes. Now number two on the test has a bunch of circles. And it says, state the number of possible common internal tangents. So I use the letter I for internal, and the number of possible common external tangents. So I use E for external for each pair of circles. So you're going to have two answers on each one, like I wrote on the test. You will have internal tangents and external tangents. Now, if you look at your notes at section 8.2, like I wrote on the test, it gives you the definitions of internal tangents and external tangents. Internal tangents means that they cross the line that connects the centers of the circles together. Okay? So if I had two circles like this picture right here, I can draw an internal tangent that would cross the line that connects those two circles together. Okay, there would be a line going from, whoops, that's too light, you don't want to do that. Okay, you would have a line connecting the circles, right? Circle centers. There's one internal tangent that can be drawn, because remember, a tangent only touches the circle like at the one point. It's a point of tangency. So you have the point where the two circles touch, and that's where the line is going through as well. So this would have one internal tangent, and then for external tangents, they don't cross the line connecting the two circles together between their centers, but they still touch both circles on their outside, okay? So external tangents would go, whoops, I can't draw. You would have one on the top touching the top of each circle, and one on the bottom touching the bottom of each circle. Okay? Now, of course, it's kind of hard to draw where I only hit it exactly at one point up here on the markers. So it would have two external tangents. So that's what you're doing on number two. I suggest actually seeing if you can draw it. If you can draw it, then you can count it. But your answers, they're either going to be 0, there's going to be 1, or there's going to be 2. Those are the only three numbers you should use for your answers on number 2. There's either 0 tangents, 1 tangent, or 2 tangents. You're not going to have more than 2. Okay? So for every single one of these, you're going to have 2 answers. You have your internal and your external. Okay? So I did one example up here. Now I've got another example. These 2 circles aren't even touching. I'm going to do the same concept. Internal tangents would cross the line that connects the 2 circles together. So here's the center, here's the center. So there's a line connecting those 2 centers together. Okay, so if I have an internal tangent, it's going to touch each circle and cross those lines. Okay, so it's going to go, I can have one that goes like this. And we had some like this in the book. So you can have it crossing inside here. They're still touching each circle at one point, but they're crossing inside there. So the internal for that one is 2. And then the external, is it going to be the same concept as we had on the other example? Okay. You're going to have going like this. Whoops. And on the bottom. So for the external, you're also going to have 2. Okay? So if you did print out your test, and you're looking at these, remember 2 tangents, for number 2, tangents touch the circle in only 1 point. You're going to have 2 answers for each one. You're going to have how many times you have an internal tangent that crosses the line that connects the centers. This one had 1, this one has 2. And you're going to have external tangents. Your three answers choices are either 0, 1, or 2. Okay? So that's what you need for number 2. Understand what I'm talking about on there? There's 2 of them everybody should get right because those pictures are similar to the ones I just did on the board. For those of you paying attention. Okay? Now, number 3, for number 3, there's not a lot I can do with that. It's all the theorems and stuff. Okay? Your theorems and definitions that you had. It tells you what 3 sections you're looking at. I wrote on there, section 8.1, 8.2, 8.3. So you're looking on section 8.1, 8.2, and 8.3, and looking at those definitions, those theorems that I have on your notes paper, and then you should be able to find all of these in those 3 sections and tell whether it's true or false. Okay? There's nothing else I can really do for that, to go over that with you. They're true or false. I told you where to look on your notes. Okay, so that covers the first page of the test. Okay, we good?
Yeah.
All right. Number 4, same concept of what I just said for number 3. It says complete each postulate or theorem. These are all on your notes. I tell you it's in 2 sections. I told you it's in section 8.1 and 8.4. So those are the 2 sections of your notes that you look at for the postulates and theorems that it has on number 4, A, B, C, D, and E. So you read the thing on the test, like part A says, if a line intersects the interior of a circle, then it contains a blank of the circle. Then I'm going to look in my notes for section 8.1 and see if I can find something that sounds almost exactly like that. Put the word in that would make it true. Okay. So that's what you need for number 4. Okay. Everybody kind of good with that? It's all there. The number 3 and number 4. Well, number 1, number 3, and number 4, if you actually filled in your notes, or you've got them in your book too, because you've got your book at home, so you should be able to answer those. Everybody should get those right. Okay? And everybody should hopefully be able to do number 2. Everybody should at least get 2 out of the 5 right on number 2, because I drew the pictures up here for you. Okay? Now, we're going to roll around over here. This that I have drawn is some stuff that we're going to look at for number 5 and number 6. Okay? This is some stuff we're going to look at for number 5 and number 6. Now, when you're looking at these, I put on here that this is stuff that's all in section 8.1. So if you're looking for examples, other examples to look at your book in section 8.1. Look at the work we did from section 8.1, and you will see ones that have this. In our notes for section 8.1, we had a lot of stuff about chords and radii and different things, okay? So the biggest thing is if you have a radius is perpendicular to a chord. This is in section 8.1 if you're looking at your notes. If you have a radius perpendicular to a chord, remember that's what that little box means. It bisects the chord. What do I mean by the word bisects? Yes, Javier, cut it in half. I guess.
Cut it in half.
Okay, so that means whatever this side is, this side's going to be the same thing. Okay, so if the whole thing is 30, HD is going to be half of 30 or just 15. And they may have units on your answers. They may have feet or inches or whatever. So if they give you units on your problem, then make sure you put units on your answer. okay? Now on this one, it says if MG is congruent to MH. MG and MH are these segments right here. If they are congruent, that means the two chords are a fancy word that we have called equidistant from the center. Okay, so this is still, it's something that's found near the end of your notes in section 8.1. Okay, if the two chords are equidistant from the center of the circle, then the two chords are going to be what to each other? If the two chords are the same distance from the circle, they're going to be congruent.
Right.
So if AE, this chord is 25, then BD will also have to be 25. Okay? So that comes from this right here. Chords are equidistant. So they are congruent, okay? Chords are equidistant, so they were congruent, okay? On this one, radius was perpendicular to the chord, so bisects the chord, okay? All of this is stuff that's on your notes from section 8.1, but that's where that stuff's coming from, okay? Now, I hadn't finished writing this next one up here. And that's when I realized what time it was, and then my computer was not wanting to let me log in, and so there we go. It says, all right, so we've got AE and BD are equal to each other. So that's our two chords are congruent, and they're both equal to 16. And then we have and then we have MC, which is a what of the circle? What is MC? Anybody know?
Diane, no, it's
The radius.
there you go, radius.
The radius of the circle, and it's 10. Okay? And what we're going to try to find is CH, which is this little piece of the radius there. But we've got some things that we know. If these chords are congruent, then that means they're also equidistant. It goes back and forth. So if the chords are the same length, these are still the same length. Okay? What do we know about all the radii in a circle? Congruent?
Yep.
Yeah, congruent, okay? So this is one, trying to get my paper back. All right, this is one that we're gonna do. All right, so if AE and BE are the same, and they were 16, that means half of it's gonna be what?
8.
8. Okay, so that we start with that. Sorry, my throat is like blah. All right, so now we have that, right? We have from here to here is also going to be a what? Radius. What
Radius.
about all the radii? They are what?
Congruent.
Congruent. So if one radius is 10, this radius is also
10.
10. And we're trying to find this little piece here, but to be able to find it, we can find this part here first. So we can use what theorem that we use with what triangles on this? Starts with a P, the big long word, half of you can't say it right.
Oh.
Pythagorean.
Pythagorean theorem, okay? So we can use the Pythagorean theorem. So when we go to do the Pythagorean theorem on here, what we're looking for is one of our legs. So I'm going to say that's x squared. I'll move the camera down just a minute. Plus my other leg, which was half of my chord, 8 squared, is equal to my radius squared, which was 10 squared. Okay? So that's what I'm working out there. Okay? So x squared plus 8 squared is 64 equals 10 squared, which is 100. Then remember, your goal is always to get the x by itself, right? So I'm going to subtract 64 from both sides. So I have x squared equals 36. Now, when you have a square root, the opposite of a square root is, when you have a square, I just told you what it was. When you have a square, the opposite of squaring something is taking the square root. So whatever you do on one side of the equation, you have to do on the other. So the square root of x squared is x, and the square root of 36 is 6. So I found that this little piece up here, from the center of my circle to the h, is equal to 6. Is that what I was actually looking for in the problem? Is that what I'm looking for in the problem? Michael?
No.
No, I wasn't looking for that. I was looking for CH. So if I know the whole thing here was 10, and I know from here to here is 6, may I just do what? You there?
I don't know.
Huh?
I don't know.
Okay. Look at our picture, okay? Let's look at our picture. The whole radius, MC, was 10. We just solved our Pythagorean theorem to find from M to H was 6. I just want this little piece from C to H. So if the whole thing's 10 and this part's 6, what am I going to do with those two things to find it? You're going to subtract. So I'm going to take 10 minus 6 and get 4. And if it's inches or centimeters, whatever unit of measure they have on there, okay? So that's what you're doing. So these are more like what you do on number 5. Number 5 had 2 parts. And this is like what you're doing on number 6. Okay? So everybody got that?
Almost.
Almost. These
Yeah.
are like number 5. This part's like number 6. Okay? Then you'll notice the next problem that you have, if you looked at your paper, was you don't do you skip number 7, because number 7 was a weird problem, so we weren't doing that. So we went to number 8. On number 8, it's very similar to all that stuff that we just did for the quiz 2-3 the other day. Okay, so that's the part that we went over, and we went over, and we went over, and we went over, and we went over. Okay, so it's using our basic facts about our central angle and its arc, and our inscribed angle and its arc, and also the fact that half a circle or a semicircle equals how much?
180.
180, and an entire circle equals how much?
360.
360. Excuse me. So that's what we're doing on number 8, okay? So I'm gonna just put some basic stuff up here for that to help guide you through on that, but I wanted to make sure everybody's got down for 5 and 6. We good? All right. For number 8, it says segment BE is a diameter of circle G. So I'm reading the problem from the test. So if it's a diameter, it means it does what to the circle? It cuts it in,
Two.
right? It cuts it in half. So I'm going to draw something similar to that where it cuts the circle in half. So y'all know I can't draw, so I'll try. I have my circle. This is A, B. This is my center of my circle, R. So AB is a diameter. It cuts the circle in half, right? Okay. AB cuts the circle in half. All right. So I have an angle here. And we'll do another angle kind of this way. Okay. And we'll use that to find some stuff that'll help you with question number 8. Okay. So first of all, we said AB is diameter. Okay. So we have semicircles in this picture because semicircles are half the circle. The diameter cuts it in half. So arc ACB is a semicircle. Because if I start at point A, go around through point C down to B, that's halfway around the circle. Or I can have ADB. If I go from here down this way to point B. Okay, so I've got 2 semicircles. Remember, semicircles equal 180 degrees, right? Everybody understand that part? That's the circle in half, the semicircles, 180 degrees. Okay? Now, we have an angle here that has its vertex at the center. So angle ARC is a central angle because its vertex is at the center. Now this vertex angle, its vertex is on the circle. So angle ABB is what type? It's not central, but it's inscribed. Inscribed angle. So what it's going to do is it's going to give you some angle measures on there. Okay, so it may tell you, let's say this one is 64 degrees, and we'll say this one's 28 degrees. Okay, so that's what we have so far. Okay, so on here, if this is 64 degrees, okay, it's equal to 64 degrees, then arc AC will equal 64 degrees because the arc that it cuts off of the circle is the same measurement as its central angle. The inscribed angle was equal to 28 degrees. Its arc is twice as big because the inscribed angle is equal to half of its arc. So if the angle's 28, I'm going the opposite way to get the arc. I'm going to take 28 times 2 and get 56 degrees for my arc. Okay. Now, looking at some other things that we have on here that you could do for number 8. We had already said we've got our semicircles, right? If I want to know arc CD, what could I subtract from to find it? I know this half equals 180, right?
Oh, yeah, 180.
I know this part is 64. So if I take 180 minus 64, then arc BC will equal
Ooh, I don't know. 116.
116. Okay. What if I wanted to know the measure of ABC? That arc. If I'm talking about arc ABC, I'm going all the way around the circle. I'm going from here all the way around through point B to C. So it's everything except this little piece of the circle. So if it's everything except that little piece, you're going to take the entire circle minus
Wow.
4
That's fine.
and get
290.
200.
Oh, it's close.
Okay. So this is similar to stuff that you also had on quiz 2 and 3, which some of you, I told you, you could go back and try to fix stuff on there too. Okay. So for number 8, part A, it's talking about naming the semicircle. So you just use 3 letters with a little arc symbol. On part B, it wants to know an arc congruent to arc CD. So first of all, you have to figure out how big arc CD is. And then find the missing arcs in the circle. By taking your angle and multiplying by 2 when you got an inscribed angle. And you can find one that's the same. Measure of arc CAD is like what we just did here. So part C is like this. Part C is like this. You take 360 minus the part that's cut off. Okay. Okay, this is part A. This is part C. You use this stuff here for part B. Okay, multiplying by 2. And part D. Remember we talked about angle addition. You can add 2 parts to equal the whole arc. So if I know this part and this part, I can add to see what the whole thing is. So that's what you're doing on part D. Part D is arc addition. You add the 2 smaller parts together and get the big one. And then part E. On part E, what you're going to do is flip my page. Maybe, maybe not. Part E, you've got half the circle, so you're going to take 180 minus the arcs that you know, and that'll equal the one that you need. Okay, so that's for number 8. Okay. Now, when you start getting into like number 9, number 10, number 11, those are all like what we did repeatedly on those first examples and stuff the other day. Okay, so with those, what you have is we've got our different types of arcs. Remember, we already said central angle is equal to its arc. Okay, an inscribed angle is half its arc. Inscribed angle means vertex on the circle. Okay? Inscribed angle has the vertex on the circle. Now, if you have an interior angle, that means the 2 lines cross inside the circle. You have an interior angle, it's half the sum of the arcs. And if it's an exterior angle outside of the circle, it's half the difference of the arcs. Okay, so with all the ones that we did the other day, and with the ones in your book for the sections that I told you, you should be able to find ones that look like what you're doing on 9, 10, and 11. Okay. But it's using that stuff there. So let's look. Whoops. Apparently I don't want to talk anymore. I got all that down?
Yep.
Okay. Gucci. A little bit. Okay, so here's what we're going to talk about. So on number 9, put it right here. On number 9, part A, you look at what kind of angle it is. Everybody tell me if you got your picture. Inscribed, so it's half the arc. Part B, you use that. Let's see, part C. If you know the angle, you take 2 times the angle to get the arc. Part D, you take 360 minus all the other arcs. And then for part E, the angles of a triangle add to equal what?
360.
The angles of a triangle add to equal what?
180. I missed.
180. So you have, that's some stuff for number 9. Number 10's easy peasy. 10A, 10B. Okay, if you, see, 10A, yeah, whoops, A, you got a central angle. Then you got on B an inscribed angle. And on on C, whew, you got an interior angle. So, and we went over all those. You have that over there on the side. Number 11, for part A, you have an exterior angle. And part B, you do 360 minus all the arcs. To find the arc that you need, and then you use that as an inscribed angle. So, and then for 13 and 14, I put the formulas on there. We did several examples of those, and I told you what section they're from. Okay, so I'm going to back up a little bit. Trying to get where the glare is not right on there. So I've got some stuff to help you with 8, 9, 10, and 11. It tells you what type of angle you're looking at. You've got your formulas over there. So you work on getting those down, and then you work on finishing up what?
The test.
Your test. Now, so I should get test pictures of that sometime over the weekend. And then Monday, also make sure that you filled in your notes for chapter 9. Because starting next week, we'll go through chapter 9. And chapter 9, we're going to do it really quick. And chapter 10, we're going to do fairly quick. Because those are ones that they're pretty easy to do fast because it's just a lot of formulas and stuff. But they're basic formulas that you can just plug numbers in and get your answer. Okay? So make sure you have this stuff down that you need. If I need to move it again where you can see something that you didn't get, let me know. If you've got everything down that you need, then you can log out and work on it. And hopefully everybody does fairly well. And I'll see you on Tuesday.
Okay.
Okay?
Bye.
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 Bye.